Welcome to Friday Happy Math Hour. So they're going to go ahead and put the link for those of you that need to go to the 1324 class, and then we're going to stay here for the 1314. So today we're going to be looking at finding zeros of polynomial functions, and this is for section 2.5. So in the previous Friday Happy Hour, we were looking at these zeros here. And so we also talked about when a zero is going to cross, like in this example, or when it's going to touch. And so a zero touches whenever it's repeated an even number of times, and it crosses whenever it's repeated an odd number of times. And then just going back really quick, we also talked about the end behavior. So what happens on the right side and the left side. And so today we'll be able to put everything together. Okay? So one of the theorems that we have in our pre-calc class is the fundamental theorem of algebra. And this theorem talks about the different types of zeros that we have. And so what this theorem tells us is that if we have 1 0 in the complex number, what you want to remember is if you have 1 0 in the complex number, then it's, give me a second. If you have a 0, then it's, I just went blank on the word. Help me, Ruben. It's conjugate. There we go. So its conjugate is also going to be considered a 0. So the degree of a polynomial also tells you how many zeros we're going to have. So if you have a degree of 3, then you're going to have 3 zeros. Some of those zeros might be complex numbers. And so we'll see some examples in our later on today. So here we have determine the number of zeros of a polynomial function. And so to determine the number of zeros, we're going to be looking at the degree. So our first polynomial has degree of 3, and the degree is found by looking at the largest exponent, so in this case 3. And so this first example is going to have 3 zeros. The second example, the degree is going to be 6. So it's out of order. It's not in descending order, but the degree is still going to be that highest exponent. So in this case, 6. Okay, so let's go ahead and find the zeros. So these examples we've been looking at from chapter 1. So the first one, we have f of equal to x minus 2. To find the 0, we're looking at letting y equal to 0. And then we solve for x. So in this case, x is equal to 2. And so we have a line. And here's our 0. Notice it only appears one time. That's why the line crosses. Okay, so let's go to B. We have f of x equals x squared minus 6x plus 9. If we want to find the 0, we set y equal to 0. And at this point, since this is quadratic, you have options. You might be able to factor. And again, not everything factors, but that is one option that you might have. And then you have the quadratic formula. And in some cases, if it's set up in the right way, then you can use the square root property as well. Okay, so in this example, I went ahead and factored. And so my zeros are x equals 3 and x equals 3. And since it's the same 0, then notice that the graph touches and then it turns. Okay, and then we go to letter C. And so this is just an example of a polynomial that has complex numbers. And so here we have our 3 factors. And as you notice, x minus 2i and x plus 2i are conjugates of each other. And so my zeros are 0, 2i, and negative 2i. So when we graph a polynomial with complex numbers, the complex roots do not show up on the graph. So we only graph the x equals 0 here. Okay, but even though we can only see 1 0, there's still 3 zeros in total. Okay, so let's go ahead and find the zeros of a polynomial function. And here they're telling us that x equals 4 is a 0. And so we're going to go ahead and use synthetic division, which is something we did last week. And since they tell me that x is equal to 4, then I can use that to set up my synthetic division. And then for my polynomial, I'm going to take the coefficients. So in front of x cubed, we have a 1. We don't have an x squared, so I'm going to use a 0 as our placeholder. And then we have, in front of x, we have a negative 13, and then we have our negative 12. So if we do synthetic division, we bring down the 1, times 4 is 4, plus 0 is 4. 4 times 4 is 16, plus negative 13 is 3. 4 times 3 is 12, and our remainder is going to be 0. And as Mr. Scarizales put in the chat, it's going to make us happy because now notice what happens when we get our quotient. So here we have our 1, so that's going to be x squared. Our 4 is going to give us negative 4x. And then 3 is going to give us positive 3. So what happens is we went from a polynomial with degree 3, and we're kind of breaking it down to something that's quadratic, because once it's quadratic, then we can apply factoring or quadratic formula. In this case, it does factor, and so I can set each polynomial or each factor equal to 0. So my zeros are x equals 3, x equals 1, and then the last 0, don't forget, is the x equals 4. Okay. Now this example is nice because they gave me 1 0. But what happens when they don't give you any zeros? Okay. So for example, here, find the zeros of the polynomial function, and they don't tell me they don't even give me 1 0. Okay, so that is the difference between this example and the previous one. And so what are we gonna need to do? So in order to help us, we could test any number out there to see if it's a 0, but there's an infinite amount of zeros. So there's a whole bunch of possibilities, right? And so we don't want to test everything out there because we might never finish. In fact, we will never. And so we introduced the rational zero test to help us look at a smaller set of possibilities. Okay, and so to use this rational zero test, we're going to set it up this way. We're going to find the factors of our constant term, which is this last number if it's in descending order. And then we're going to find the factors of the leading coefficient. So remember, your leading coefficient is in front of the x with the largest exponent. Okay, so let's review what a factor is. So if I have the number 8, the factors of 8 are all the numbers that you can multiply to give you an 8. So 1, 8, 2, and 4, these are all factors because if I multiply them, I get the number 8. So if we look at 24, the factors of 24 are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Okay, so those are the factors. And so let's go ahead and practice. So in WebAssign, if they ask you to find, the instructions are going to say, find the possible rational zeros of the polynomial function. And so we're going to use step 1. We're going to use the rational zero test. So first, we need to find what the constant term is. We need to find the leading coefficient factors, and then we're going to divide them. Okay, so let's go ahead and start with the factors of our constant term. Our constant term is -9, but I'm just going to use 9 here, but you'll see that whether it's negative or positive, we're going to be using all of them. Okay, so the factors of 9 are 1 times 9 and 3 times 3. So I'm just going to write 3. Our leading coefficient in this case is 1. So I'm going to write the factors of 1, which is just 1. So if we divide the factors of the constant term, and notice here I'm going to write plus or minus 1, plus or minus 3, plus or minus 9. And then for 1, I'm going to write plus or minus 1. Now we're going to divide. So 1 divided by 1 is 1. 3 divided by 1 is 3. 9 divided by 1 is 9. Okay. So you would enter your answer. All the possible rational zeros are 1, 3, plus or minus 1, plus or minus 3, plus or minus 9. However, on WebAssign, they don't have a symbol for plus or minus. So you have to enter your answer individually. So you would enter 1, or you would enter -1. And then sometimes they ask you to enter your answer as from smallest to greatest. So if they say smallest to greatest, in this case, we would enter -1, -3, or we would actually enter -9, -3, -1, 1, 3, and 9. Okay, and so you want to enter them separately. Let's try another one. It says find, oh, so going back. So now that we have, let me go back. So these are the possible zeros, okay? And don't forget the commas, because then it'll count it wrong. So these are your possible zeros. So remember earlier, we mentioned that if we want to find the zeros, we could check the numbers, but we don't want to check just whatever random number. Instead, from an infinite amount of numbers that we had, now our list is going to be 8, right? 2, 4, 6, or 6. So we're going to have 6 zeros that we can check instead of an infinite amount of numbers. So after you do the rationals, the possible zeros, then we take our list and we're going to use synthetic division with our list. So I always like to start with 1. And if 1 doesn't work, then I check -1. And then I go on to the next list, okay? So all I need is if 1 works, then I'm good. So here I'm gonna set it up. So 1 is coming from this possible list. All right, so then we have x cubed, I'm gonna write the 1. And then we have x squared is 1. X has a -9, and then we have a -9. So we apply the synthetic division, bring down the 1. 1 times 1 is 1, 1 plus 1 is 2. And then 2 times 1 is 2, plus -9 is -7. And then we have -7 plus -9 is -16. And unfortunately, we need the remainder to be 0. So in this case, is not 0. That tells us that 1 is not a 0. Not a problem. Now we're going to try the next one. Let me see if, oops. Okay, so we'll try -1. So we do the same process. 1 times -1 is 1, plus 1 is 0, times -1 is 0, plus -9 is -9, and we keep going. So now we can see that we got a 0. And so that makes us happy because x is equal to -1 is a 0. But more importantly, we can take our quotient, what's remaining here, since we started with x cubed, this first number here, 1, our quotient is going to be x squared for the 1, x squared. There's no x, and then we have our -9. So we can take our quotient and set it equal to 0 to find the rest of the zeros. So we're going to add 9 on both sides, take the square root, and simplify. So we get x is equal to plus or minus 3. So my zeros, my coefficient, my degree was 3, so I need to have 3 zeros. So my zeros are 3, -3, and -1. So we get the 2 zeros from here, and then we get the -1 from the synthetic division. Okay. Any questions on that one? Okay, so later on in this presentation, we're going to need the factors. So let me talk about the factors. So once you have your zeros here, if we move our constants to the left side, I would have to add a 1 on this side to get 0. And then I would have a +1. So x plus 1 is my factor. And if I move the -3 over here, I would end up with x plus 3. And if I subtract 3 on both sides, then I get x minus 3. So we'll use these for some other problems in a little bit. Okay, so let's try this problem. Find the rational zeros of the function. So the first thing we want to do is use the rational zero test. My constant term is 1 or -1, and my leading coefficient is 2. So the factors of 2 are 1 and 2. So if I divide these, I get plus or minus 1 divided by plus or minus 1 and plus or minus 2. So if we divide, then we end up with 1 divided by 1 is 1, and 1 divided by 2 is a half. Okay, so these are my possible zeros here. And so we only have 4, so we don't have a long list. And so we're going to start checking them to see if they are zeros. Because remember, these are possible rational zeros. It doesn't mean that they are, so we need to check them. So we'll start with 1. So we have our x cubed, so my coefficient is 2. And then our x squared is 3. I don't have an x, so I'm going to use 0. And then I have a minus 1. So we're going to bring down the 2. 1 times 2 is 2, plus 3 is 5. 5 times 1 is 5, plus 0 is 5, and then 5 times 1 is 4. So unfortunately, it didn't give me a 0 in my remainder. So that means that x equals 1 is not a 0. So we try negative 1. So we bring down the 2 times negative 1 is negative 2, plus 3 is 1. 1 times negative 1 is negative 1, plus 0, negative 1 times negative 1 is going to be a positive 1. And so that's going to make us happy. Since we have a 0, that means that x equals negative 1 is a 0. So now we can take that information in front to get our quotient. So my degree for my quotient is going to be 1 less than the x cubed. So instead of x cubed, we're going to start with x squared. So I have a 2 times x squared, and then the next one would be x, and then we have the negative 1. So my quotient here is 2x squared plus x minus 1. And this is a good thing because it's quadratic. So the whole point of this method here is to break down the degree 3 into something that we feel more comfortable or have more methods of solving. So since it's quadratic, now we have options, right? We have factoring, or we have quadratic formula. So go ahead and continue. So I'm going to try to factor. And when you're trying to factor, if you're taking an exam, especially a paper exam in class, and you might have 50 minutes to do it, I always like to tell my students, give yourself a minute. If you can factor it in less than a minute, then go ahead and move on to the quadratic formula because this might not even be factorable. Okay, so here are my factors for this polynomial. So I can set each factor equal to 0 and solve for x. So I get 2x equals 1. So half is a 0 and negative 1. Okay, I should have 3 zeros. So I have my zeros are x equals negative 1, x equals a half, and x equals negative 1. So I have 2 repeated zeros. So that means that at x equals negative 1, the graph is going to touch and turn. Okay. In a little bit, I don't remember if I have it here, but we might do some graphing ones hopefully. Okay, so again, the multiplicity of negative 1 is 2, and it's repeated an even number of times. So let's try another one. So we have t squared minus t to the 6. And so if we apply, again, there's other ways to solve this polynomial, okay? So one of the things you could do here, for example, is you could factor out a t squared and go that method, right? So you would end up with t squared parentheses 1 minus t to the 4th, and then you can factor that out as well. And so for some of us, factoring works better, and that's fine. So again, you could factor at the beginning to try to get your zeros, but I'm going to go ahead, since we're practicing with the zero tests, we're going to go that route. Okay, so we have no constant term, so we have 0 is our constant, so my factor is just 0, and then my factors of 1 is just 1. So we divide 0 divided by 1, then my possible zeros is 0. So we only have 1 point to check. So we're going to go ahead and check that point. And I'm going to use synthetic division. So I have negative 1 is for 6, t to the 6. I don't have a t to the 5th or a t to the 4th or a t cubed. And then I have a t squared. Then I don't have a t and I don't have a constant. Okay, so if we keep track of all these zeros, then we bring down the negative 1 times 0 is 0. And if we keep doing this, then we get 0 times 0 is 0. And then we have 0 times 0 is 0, and so on. Okay. So let's keep doing this, and then we bring 1 plus 0 is 1, and 0, 0. Okay, so we just applied synthetic division. And so we get our quotient. Since our degree was 6, we start with 1 less degree of 5. So we have negative t to the 5th. This 0 is t to the 4th, t cubed, t squared, and then we have t. And then we have our constant. So we don't have a method for this. Again, you could factor at this point, and so you can do that. But I'm just going to start the process again, because sometimes this won't be factorable. So you would need to start the process again. And so that process is, if you find the zeros, the possible zeros, it's only going to be a 0. So t to the 5th is negative 1, t to the 4th, t cubed, t squared, and then you have t and your constant. So we bring down the negative 1 times 0 is 0. We add these, we get 0, then we come down to 1. Since we had a degree of 5, 1 less degree is 4. So we have negative t to the 4th plus 1 is our quotient. And so at that point, I'm going to go ahead and factor. But if you don't want to factor, you could have continued this process of synthetic division. But here we can factor. So we have negative t squared minus 1, and t squared minus 1 is equal to 0. Set each factor to 0. So I'm going to go ahead and add 1, divide by a negative, take the square root. So we get t is equal to the square root of negative 1. I can simplify this. We know negative 1, the square root of negative 1 is plus or minus I. And then on the next factor, I'm going to add 1. So we get plus or minus 1. So we should have 6 zeros. So let's go ahead and look at all those zeros. So we have t equals 0 is from the first synthetic division. And then t equals 0 is from the second synthetic division. Then we had t equals 1 is right here. T equals negative 1. T equals I. And then t equals negative I. So these are our 6 zeros. And I went ahead and graphed the polynomial so you can see that at 0, it touches and turns since it repeats it twice. And that 1 and negative 1, it's only crossing. Okay. So again, let me reemphasize that at this point right here, if the question says find the rational zeros, from the beginning, you could have just factored out and you would have had, let me go ahead and I think we'll have enough time. Let me just get my pen just so you can see the difference. So from the beginning, you could have factored out a t squared. Oops, I'm sorry. Let me write it again. So if we factor out a t squared, then we get 1 minus t to the 4th. Okay, and then you could have set these equal to 0. So you would have had t squared is equal to 0, and 1 minus t to the 4th is equal to 0. And then you would have just solved for t, and you would have ended up with these solutions. Okay. All right, so we can look at another example. Okay, so I guess I had it on my next slide. So the second way was, again, you could have factored out the t and found these zeros. Okay. So it's up to each one of us, right? We provide you the tools, and then whatever you feel more comfortable with, then that's what you would go with. Wow, so this one looks very exciting, right, Mr. Garizales? Now we don't even have a degree 3, we have degree to the 4th power. Okay, so to factor this from the beginning is probably going to be hard or impossible. So no problem, we have the rational zero test. So let's get these factors of 24. We have 1 times 24 is 24, 2 times 12 is 24, 3 times 8 is 24, 4 times 6, 24. And then my coefficient, leading coefficient is 9. So we have 1, 3, and 9. So if we divide these, it will look something like this. And now I need to divide 1 divided by 1, 2 divided by 1, 3 divided by 1, 4 divided by 1, and so on. 8 divided by 1, 12 divided by 1, 24 divided by 1. And then we start with 1 divided by 3, 2 divided by 3. 3 divided by 3 is 1, so you don't have to write it again. 4 divided by 3, and so on. And then we go 1 divided by 9, 2 divided by 9, and so on. And so my list is going to look like this. It's pretty long list, but it's not as long as infinity, right? So we are happy that it's not as long as infinity, and we only have a little bit. Our list is small compared to infinity. So the only problem would probably be when you enter it on your computer for WebAssign, because you would have to enter it as individuals, right? You would have to put a 1 and then comma, -1, comma, and so on. But hopefully they don't give you one that is super long. All right, so now we just got to check these. Should I start with 2/3, Mr. Carizales? Would that be a good starting place, or what is my starting place that I should start with? That might make me lucky and hit that 0. Yeah, always start with 1, right? If 1 doesn't work, go to -1. If that doesn't work, go to 2, and so on. Okay, so let's go. So we have 1. I'm going to bring down the 9. And then 1 times 9 is 9, 0. We get 0 plus -58. And then we keep going and we get 30. So that didn't work. So let's try -2. I probably tried -1. It might have not worked. So, and then I probably tried 2. So -2, let's see if that works. So we get -18 plus -9 is -27 times 2 is 54. It gives me a -4 times -2 is 8 plus 4 is 12 times -2 is -24. So we end up with 0. So that is good. So now our quotient, since we started with x to the 4th, what degree is my quotient going to start with? It's going to start with 3. Okay. So we have 9x cubed minus 27x squared minus 4x plus 12. So now we have this polynomial. So at that point, you might be able to factor, right? You might be able to factor. You might be able to factor by grouping. So grouping might be an option right here. But for those of us that prefer not to do factoring or do grouping, or maybe you forgot how to do the grouping, then it's not a problem. We'll try again. Okay. So now you have this new polynomial. So we can get the factors of 12. So these are the factors: 1, 2, 3, 4, 6, 12. And then 9 is 1, 3, and 9. So these are going to be my factors. So I go ahead and choose one of them to test. And I'm going to go ahead and choose the 3. I probably chose 1 and stuff before and it didn't work. So let's use the 3. I bring down the 9. 9 times 3 is 27. I add it to -27. I get 0 times 3 is 0. And then -4 times 3, -12, we get 0. So that tells me that x equals 3 is a 0. So now my quotient is going to start with an x squared. Since we had x cubed, now we start with x squared. So 9x squared, there's no x, and then -4. So now this is quadratic, so we finally broke it down to something that we can apply the factoring quadratic formula, or in this case, I can do the square root property. So I'm going to add 4 on both sides, and I'm going to divide by 9. And now I can take the square root. So the square root of 4/9 is going to be plus or minus 2/3. Okay, so let's, how many zeros should I have? I should have 4 zeros. So altogether, we're going to have our x equals -2 was the first one. Then we had our x equals 3. And then we had our plus or minus 2/3. So these are my zeros here. And again, on the computer, be careful because sometimes they already have that x in front. So sometimes the computer is already going to have x equals, and then they just want you to enter your actual zeros. And you want to separate them with commas. Okay. And then if they might ask you to put it in this and from smallest to greatest. Okay, so my factors again, since we're gonna be using them here in a second, we have x plus 2, x minus 3, and x minus 2/3, and x plus 2/3. Okay, so let's go to the next example. So now we're gonna actually sketch the graph, okay? So, and we already did the actual work, okay? So we're just gonna bring in the information. So when you're graphing these, you want to get all the possible zeros, which we previously worked out in the slides. If you want to go back, again, you can always download the PowerPoint above my blue arrow here. There's an arrow with a square around it. Just click on that, and it's going to allow you to download the PowerPoint. Okay, so let's bring that information. These were my zeros. And let me just keep going. So these are the zeros here, and now we're going to sketch the graph. Okay, so remember to sketch the graph, we want to know what the end behavior is, the multiplicity of each zero, does it touch, does it cross, and then we actually want to find the zeros, which we did in part B here, and then the y-intercept is always a good one to have. So in this example, if x is 0, then our y-intercept is going to be -9. Okay, so I'm going to break it down a little bit further. So the end behavior, remember these are the possible end behaviors where it rises to the left, rises to the right, falls right, falls left, or rises right, falls right, falls left, rises left, falls right. So in this case, we have a cube. So our graph is going to be like this one or like this one, and it's odd. And then our leading coefficient is positive. So that's going to be the behavior is this one, rises right and falls left. Okay. Then our zeros are -3, -1, and 3. None of these are an even multiplicity, so that means that our zeros are going to be crossing at each of these points. Okay, so then we have our y-intercept where we let x equal 0, and if we do the work, we get -9. And then pick additional points is always last, but after you have plot this information. Okay, so we plot our zeros, apply the end behavior, and I think the graph didn't show up. So let me go back so we can just do it there. All right, so let's graph it here. Let me get my pen. Okay, so we'll check if it's at the end. Let me just emphasize something here really quick. So we have -3 is right here, and then we have 3. And then our intercept was at -9, so I'm just gonna make the -9 here. So when you apply your 3 points, apply the end behavior. So the end behavior rises on the right, so it's gonna go like this. And at this point, it's crossing, so I can just sketch a little bit down because it's gonna cross. And then on the left side, it falls, and my behavior crosses, so it's gonna go this way. So when you wanna, oh, I went to -1. Where's -1? All right, so right here. So when we want to fill in the gaps, right, we need to know what happens in here. That is where the additional points come into play. So you want to pick some additional points between your last x-intercepts on the right and the left. Because if I pick a point here, it's not going to help me because I know that the answer better be somewhere down here. But I don't know what's going on here. I'm assuming it might go something like this, but we want to know like how far down or how far up it's going to come. So the additional points is going to be helpful here. So I think Mr. Garizales, I think he's right. I think we have the graph at the end. So let me go ahead and scoot over to the end. So the points that I'm picking are -2 for the additional points, 1 and 2. So the reason again is in between, right? -2, 2, 1, and -1. So let's see what happens with these additional points. So if we plug them in, we get a 5. And for 1, we get negative 16. And for 2, we get negative 15. So if we plot them, then here's our x-intercepts. The graph is rising right, and it's going down. And so you can see the graph is going to go down this way. But you would plot in negative 16, negative 15. So it got cut off here. Okay. All right. So let me go back over here. So again, you would just plug in your numbers, negative 16, and plot the graph, come back up. Okay, the other thing that you're going to be asked to do is to come up with a polynomial function. So what that means is they want you to come up with this answer. So we're going to work a little bit backwards, okay? So they give you the zeros, and they want you to find the polynomial. So it says find a polynomial function with real coefficients that has the given zeros. So here we have a 3 and a negative 4i. This is a complex number, so which other zero am I missing here? We're missing the conjugate. So that's the first thing you want to look at is the type of zeros that we have. So our zeros that we have are going to be x equals 3, x equals negative 4i, and x equals 4i. So I'm going to write my zeros, x equals 3, x equals negative 4i, and x equals 4i. And this is where the factors are going to be needed. So if I subtract 3, I get x minus 3, x plus 4i, and x minus 4i. So we write our polynomial f of x is equal to some number. We don't know what that number is right now, but we'll leave it as an. And then we're going to write down our 3 factors. Then we're going to multiply them out. So I always like to start with the complex number. So x times x is x squared. And then x times negative 4i is negative 4ix. 4i times x is 4ix. 4i times negative 4i is negative 16i squared. And what do we know about I squared? I squared is going to be what we can simplify in here. 4ix plus 4ix is 0. And then I squared is negative 1 times negative 16. And so we end up with x minus 3 times x squared plus 16. And now we multiply again. Okay, so let's multiply again. X times x squared is x cubed. X times 16 is 16x. Minus 3x squared minus 16 or minus 48. Gather your like terms. And so I have them here. I like to write them in descending order. And so right now, they don't give me enough information to figure out what an is. So we can just use, it could be many things right now. Just use it as a 1. And so my answer is going to be, if this is a 1, I multiply it inside. And we get x cubed minus 3x squared plus 16x minus 48. But in some problems, they'll give you enough information to figure out what an is. And I think I have one in here. So let's check. Yes, we have one here. So it says, find the polynomial function given the degree, the zeros, and the solution point. So this is a degree 4. So I should have 4 zeros, but I only have 3 listed, negative 4, 1, and I. And then they give me a solution point. F of 0 is equal to negative 8. So first, I always like to write down my zeros on this side. So I have x equals negative 4, x equals 1, x equals I. And then I'm missing that conjugate. So that's going to be x equals negative I. Write my factors down. And then I'm going to write each of the factors here. Yes, it always comes with a friend. They can be separated. So we have our factors. So let's multiply with the complex numbers. So let's multiply those out. So we end up with x times x is x squared. X times I is ix. Negative I times x is negative ix. And negative I times I is negative I squared. My ix's cancel. And so I'm down to x squared minus I squared, but we know that I squared is -1. And let's just simplify a little bit. So I get negative is a +1. So now I just need to keep multiplying. So I get x times x squared is x cubed. X times 1 is x. -1 times x squared is -x squared. And -1 times 1, -1. Okay, so we keep going. Now we're going to multiply x times x cubed is x to the 4th. X times x is x squared. X times -x squared is -x cubed. X times -1 is -x. Then we start with the 4. 4 times x cubed. 4 times x. 4 times -x squared. And 4 times -1, which is -4. Gather any like terms. So I get x to the 4th. I have an x squared here and a -4x squared. And is that it? And so this should be a negative, oh, the x cubed first, okay. So -x cubed and 4x cubed is +3x cubed. And then x squared and -4x squared is -3x squared. And then we have a negative x and a 4x is a +3x. And then our -4. Okay, so in the previous problem, we said a can just be 1. But that was because they didn't provide us with a solution point. So in this solution point, 0 represents x, and -8 is what the function is equal to, or y is equal to. So what we can do is plug that information. So our function is equal to -8, and all the x's are zeros, right? Because this is a 0. Sometimes it's going to be a number. It could be 1 or 2 or whatever it is. In this case, it's 0. So we plug it in, simplify. So we get -4, divide by -4. So we get that an is 2. So now that the an is 2, I'm going to go ahead and write it here. Now we can distribute the 2 into the parentheses here. So we end up with 2x to the 4th plus 6x cubed minus 6x squared plus 6x minus 8. So this is our polynomial function. So if you were to apply the rational zero test on this problem here, you should end up with these 4 zeros. Okay. So that was finding the section 2.5. We do have a few minutes left, so if you do have any questions, feel free to ask us. And I believe next week, I don't know if we have a session or not, but I'll let them tell you guys. But I know that exam 2 is coming up quickly, and so I want to wish you the best on that exam 2. And I guess I'll pass it over so that we can see if we have a session next week, because I don't remember if we do.
Yes, thank you, Ms. Chuka. Thank you, Mr. Carrizales, for your presentation. We do have a session next week, and I'll go over that in just a second. If you would like to download a copy of the presentation, you can go to the top right corner and click on the box with the arrow going down while the presentation is on the screen. That'll allow you to download the PowerPoint. We do want to remind everyone about the previously recorded sessions, which are available on the YouTube playlist. This session will also be available on that playlist later today. Also linked was a short survey to help us improve our TVE sessions. Please take a few minutes to fill out that survey and remember to send your student ID number to us before you log out. Before you all leave, I want to share the TVE sessions that we will have next week. Or that we will have next, I'm sorry. So at 1 p.m. today, we will have a presentation on exploring a career in libraries. And next week at 11 a.m. for Happy Math Hour, for 1314, we'll be covering exponential and logarithmic functions. And for 1324, we'll be covering systems of equations. At 1 p.m. that day, we will have a session by our EPCC Mental Health Committee. Thank you all for coming in today. We hope you all have a lovely weekend. If you have any questions, feel free to use the chat box or your mic. We hope to see everyone again next week for Happy Math Hour.